Coming up, we've got a couple of very different kinds of videos in which we're jetting over to Belgrade and Ljubljana to check out how things are done at a couple of aircraft MROs belonging to a Polish company called AviaPrime. In case you didn't already know, MRO stands for Maintenance, Repair, and Operations. It's where you take your aircraft to get serviced, checked, and repaired. That's always a fascinating thing to get a behind-the-scenes look at. But what's extra fun today is that we're going to witness a key step in the conversion of a 767 from a passenger aircraft into a freighter. Specifically, they're going to be cutting a big piece out of this 767's fuselage where a cargo door is going to be fitted. This conversion is something only a handful of facilities are certified to do. We'll also get a tour of the engine shop here in Belgrade and check out this vintage Yugoslavian facility, including some very classic aircraft. And next week we'll be headed to Ljubljana to see another company under the AviaPrime umbrella, JAT Tehnika, where they're busy working on several aircraft, including many CRJs and A320 family planes. They have some pretty interesting niche specialties as well. So join me on this late summer's day in Belgrade, Serbia, and let's get into it. JAT Tehnika is the only MRO in Europe offering the 767 cargo conversion. And this is the second aircraft they've done it on. It's a massive operation. They're working with IAI in Israel to benefit from their expertise in 767 conversions. And here's the star of the show, an old 767 that's lived out many years flying passengers and is now preparing to enter the next phase of its life as a cargo plane. And I'm just in time to catch the removal of this piece of fuselage where the cargo door will go. While I'd imagined a lot of metal being cut, actually it turns out that this is largely a matter of removing rivets, with only a little bit of supplemental cutting in certain areas.
Number three, take down.
This is the section of fuselage that's been removed. It's going to make space for the cargo door, which we can see the big old hole in the airplane behind. And funny to see these windows that you can reach your hand through. Long ago it was flying passengers, but they couldn't have imagined the state it's in now. And they're going to renew this entire thing. The whole thing is going to get not only a reinforced door, make it nice and strong again, the structure of the aircraft, but everything throughout being replaced, made new, fresh parts, fresh everything, fresh avionics, It's very impressive. The entire aircraft is being stripped, then reinforced for cargo operations and upgraded. This is basically going to be an entirely new airplane by the time it's done. Now, this is a very unusual thing to see, and quite an operation with dozens of people. They told me it takes about 4 months at this point. The first one took 6 months, and this one should take about 4 months as they've gained expertise. The cockpit especially is just nuts to look at. And they need about 60 people working on it. The engineers here say it gets a bit faster as they do more and learn things in the process, though there are always challenges that need addressing and obstacles that need overcoming to make sure it's all done correctly and according to regulations. There is so much detail that goes into this, it's incredible.
We replace all the floor beams, basically all the structure. It's a new aircraft when it leaves our facility. We put in like a rigid frame inside the aircraft, so we can cut out and the aircraft will still keep its shape. And then we put in the plug, the door plug it's called. And then we have a rigid frame again. If you remove one rivet in the aircraft, it will affect another rivet. Say it again. So basically they need to calculate, if we remove this frame, we need to replace it with 2 other frames or something like that.
Let's go check out the door plug that's going to fill in the space they just cut into the 767.
Basically the new structure of the aircraft, which is reinforced. And this is all new, so it will be, everything is reinforced, so even if we have a big hole for the door, it's still structurally, it's the same as before. And it comes to us in 2 pieces, so we need to rivet it together. High lock is like a bolt, special bolt, or a special rivet basically. And we put like a collar on it, it's called. And when it has a correct torque, the high lock shares. So you cannot take it off. The new one is with a hexagon, so basically for a socket. If you see a new one, it's like a hexagon for a socket. But now you can never remove it. As long as you install it, it has a correct torque, it shares off and you cannot remove it again. This is opening for the new cargo door. So it's like a door frame basically that we need to install. So this is basically where we install the hoist. And when we already riveted to the aircraft, we will install high locks. But at the moment it's open because of the attachment point.
See that marking on section 46 where there is no paint anymore.
Yeah.
That is the spot where the pressure valves will be from now on. You can see from here in the aft cargo, all that are new parts produced by EAE, Israeli Aerospace Industry. And according to their job cards, according to their drawings, the guys on the floor are performing installation. Every time they have a situation that there is discrepancy between drawings and the parts, they call me, I find a way how to deal it. In talks with EAE, I release the engineering approval, how they should proceed. A huge project.
Yeah.
Really, really huge.
You've already done one.
Yes.
Yeah.
On the first aircraft I was from the beginning, so this aircraft is a lot easier for me.
Yeah, that must help. Yeah.
Yes, the first one was, trying to find a way when you see corrosion, crack, puncture, whatever, and there is conversion near.
Yeah.
It was a bit in my head, how should I put it when I can't use SRAM, everything, but when I got used to it, it was easy. Okay, you understand that before we perform cutting of the entire skin, there's a lot of reinforcement that needs to be done on the frames. The entire floor needs to be removed. The old ones are being scrapped, as to say. The new floor beams are being installed that are made in IEI. The wing reinforcement is also has to be done before the entire conversion is done because of the entire load of the aircraft. For example, because the doors are being closed and you have only entrance to the left side, there should be one emergency exit, how to say, and it is made on the R2 window. So, for example, here, in case of emergency whatever, this here part of the skin is being cutted. The new one is being installed here with mechanism from the inside and the outside, which the guys can open it here, latch, and the window will open and they can assist somebody who is inside. The entire cockpit, as you can see, is being changed. The new seats are put for the entire crew that needs to go ahead, and behind them it is 9G barrier that protects the guys, the pilots and the entire crew from the load that is coming from the inside. These straps are a reinforcement of the entire skin, because in that area the 9G barrier is gonna be installed, which protects the entire cockpit from any damage that can occur while the load is being transferred here. These are all new floor beams that are made by IEI. When we received them from Israeli aerospace industry, we also received drawings, part list, everything that is needed so the guys can perform the work. Our job here is, like my manager told you, when we have deviation, we need to find a way how to figure it out. For example, the holes are mismatched, some of them need to be plugged, or airplane configuration is a problem, the floor beams can be put with frames. Create RFTAs, request for technical assistance, send it to EIE and give proposal, and their engineering with their computers and everything will see if that is applicable for this sort of repair. Wow. The conversion is going ahead, also the C-check is going with it. So they need to check every single stringer, every single frame, stringer clip, shear tie, everything to see if there is corrosion, crack or whatever, and it is our job to find a solution, either to repair it, replace it, or whatever, to bring airplane to its initial configuration. Windows are all removed, they are all inspected to see if there is any corrosion, cracks, everything. These ones are perfectly fine. Like for the first aircraft we had a lot of problems on the windows, and afterwards they're just gonna be plugged. As you can see, all of this is new structures, the new floor beams, post beams, and the stanchions. These are, as we like to say, the reinforcements of the entire airplane. But when you just look at this like this, it doesn't seem much, but every single one has some additional. For example, new stringer clips need to be installed. It's here, new L brackets. That is all the reinforcement that is proposed by IEI, their stress department, to hold the entire load of the cargo that is gonna be one day put in this area and the upper area.
Wow.
And afterwards, when the airplane is done, they're closing this, and all the floor panels with rolly brackets are being installed so the cargo can be pushed.
Wow.
Every single fuel tank needs to be checked, and the inspection needs to be performed to see if there are some sort of cracks, corrosion, whatever. Everything needs to be done in accordance with SRM plus IEI documentation, and in case if we have something that is in conversion area, then we need to find a way with IEI engineering how to proceed and how to finish that sort of a problem. But you see how they are working, so the cargo can just go on it, it will not damage it, but these are the old ones, the new ones need to be shipped from Israel and installed. And these are the floor panels that go at the end of the conversion.
So this is the assembly part of the shop, where we have the main modules, disassembly and assembly lines, if I can say, as well the balancing station. We have 8 stations, The shop is fully capable of disassembly, inspection, assembly, cleaning and testing of CFM 56-3. Every engine part that is removed from the engine needs a thorough inspection based on the applicable requirements of the technical documentation. Every of these shelves is registered by the engine serial number, by the work package, by the work order actually, and sorted out for these guys to actually do the table inspection, to provide the quality inspection that is needed for engine on piece part level. So you see the serviceable pack when the inspection is finished. It's marked with a green card, so we know that it's ready for installation to the repaired engine. So as you can see, the cleaning area is fully capable of cleaning, specialized cleaning processes that are needed to provide the part for the table inspection guys without any dirt, without any leftovers, residues of oil or fuel or burnt material while the engine was operating. So you can see here that basically we cover every part of the process from assembly, disassembly, cleaning, table inspection, and as well testing. This is the engine overhaul machining shop where we do grinding, milling, and final, I can say, protective appliance to the parts that we disassemble here. The DC-10 was bought by JAT, and suddenly there was a need to build a bigger, better hangar for base maintenance of the DC-10. So that is what happened here. We built this facility well in the 80s, and together with it the engine test cell where we are going right now for safety purposes. It's on the other side of the runway, isolated because it's a highly explosive and highly, I can say, controlled. It needed to be a highly controlled area. The project was completed in accordance with the latest standard back in 1989, and with the great support from the French company SNECMA.
And walking across the tarmac to the engine test run facility is like a quick trip through an aviation museum.
Welcome to the engine test cell facility. Here we're currently at the prep shop where the engine that is prepared for testing actually is being brought from the engine maintenance department here and prepared for the actual test. It comes on a stand like this one, connected to all of the sensorics or all of the additional equipment. Okay. Here we are at the data acquisition room. Currently, our senior inspectors here are providing the regular calibration for the preventive maintenance of the test cell, from the fire extinguisher equipment to the oil preservation control, to the compressor air control, fuel shut-off valves, fuel storage, the starting pressures that we monitor. All of these indications and the control units are basically maintained by the licensed personnel of JAT Tehnika that were sent to France for education and proper use of this very interesting SNECMA test data acquisition. This kind of door, like a vault door would look like, yeah? This is what a finished product of the engine maintenance department looks like. Prepared for shipping, preservation performed, boroscope outgoing boroscope inspection performed, and ready for the customer to install on the wing.
MROs under the AviaPrime umbrella include JAT Tehnika, Adria Tehnika, and Line Tech, which has facilities around Poland. This is the latest one to come into the fold. What an interesting place to get to take a look at. Be sure to come back next week to see a very different scene at the Adria Tehnika facility in Ljubljana, Slovenia. Hope you enjoyed this one. In Belgrade, for Flight Radar 24, I'm Gabriel Lee.